Thank you. Thank you, Sam, and good evening, everybody. By way of an introduction, 2 days ago I went to a classic vehicle event near Rochdale in my 1964 Rochdale Olympic. And in amongst the normal cross-section of vehicles that were there turned up a ex-Huddersfield Corporation 71-seater bus. And on the front of the bus, and it was marvellous, by the way, it was really well restored, but on the front of the bus there were two badges. One said Daimler, the manufacturer of the chassis, and the other said Gardner 150, which in its most basic terms means it was fitted with a 6LX engine. But actually says a lot more than that, because the fitment of those badges signified, certainly during the earlier parts or the latter part of the last century, a sense of pride by the owners and drivers of those vehicles to say, my car, my vehicle has got the best engine that's available under the bonnet. So, and we'll come back to that later in the presentation, the nomenclature of the Gardner engines and what that actually meant. So, but tonight I want to give an overview of the latter part of the company history, the part where they made diesel engines, because the early years of the company started in the latter part of the 19th century, and so I'm just going to summarise that. But towards the end of that century, they moved into manufacturing both external and internal combustion engines, and went to Barton Hall Engine Works. So I'm going to concentrate on the engines and the applications, particularly the L-series engines, which were the real breakthrough, and developments from there. Look at a number of the applications, and then look at the growth and decline of the company. Finally bringing up to date what actually happened at the end, the disposal of the assets, and what's left today. So that's a brief summary of what we're going to cover today. So here's a timeline, key events in the Gardner history. Founded in 1868 by Lawrence Gardner, who gave his name to the company. And as I say, it started off really in general manufacturing and engineering, but soon got a reputation for high precision engineering capability. And so as the technology developed towards the end of the 19th century, Gardner's was making things like dynamos and then hot air engines and so forth, and a lot of subcontract work. I think they made dentist chairs and things like that. But most importantly, in 1898, they moved to a new site. They started in Manchester, in Hume. They moved to a new site in Patricroft, near Eccles, just on the outskirts of Manchester, and set up the Barton Hall Engine Works. And that's where they remained for the rest of their operating life. And from that site, they made a range of internal combustion engines, gas, paraffin, oil and petrol. Just a brief note on World War I. Gardner was one of the suppliers nominated to manufacture tank engines. I think by that time it was acknowledged that they had the capabilities to make this sort of product. But very significantly, although the tank engines were made by other manufacturers as well, all the crankshafts were made by Gardner's, and they were made on machine tools that they designed and developed themselves. So very early on it was clear that it had this capability in manufacturing high precision mechanical parts. But the story I want to talk about really starts in 1929, the introduction of the L2 direct injection engine, initially designed for marine application. Move on to the LW, which is a very famous engine for Gardner. The L3, which is a higher volume engine, again aimed at marine, automotive and industrial applications. I'll skip through some of the other parts because they are important but not critical to the story, and then come back again and focus on the 6LX, which was introduced in 1958, which is probably the engine for which Gardner is most remembered. And then finally I'll summarise the back end of the story, the takeover by Hawker Siddeley, and what happened subsequently when it was sold to Perkins. So a brief just look at some of the names. Lawrence Gardner founded it, and then his sons and grandsons and great-grandsons were also involved in the management of the company. And key names in terms of the diesel engines were Thomas Gardner, who was the chap who really identified the opportunity for developing internal combustion engines, and then Joseph Gardner and Hugh Gardner, who were together responsible for the L2 and LW engines. And Hugh Gardner, that was in his very early days in the company. He was also the final chairman and chief engineer of Gardner's as an independent company. He retired in 1978, so he's a key player in the overall story of Gardner's. And then Clayton Flint, the first external board member. Until that time, all the board members had either been members of the Gardner family or they'd been nominees appointed from the workforce because they would fall in line with the Gardner decisions and direction. But Clayton Flint, it was subsequently acknowledged, was brought in to prepare the company to be sold, because by that time it had been acknowledged that it wasn't really going to have an independent long-term future. And then towards the end, Gardner became a subsidiary of Hawker Siddeley, and then in 1986 was sold to Perkins. And we'll come to that later in the presentation. So let's look at some of the significant designs from the L2 to the LY. The L2 and L3 were marine, rail, industrial diesels, cast iron construction, and of modular design. And they were very fuel efficient, direct injection diesels, very advanced for their time. And that really set the design concept for the subsequent engines, specifically the LW. The LW again was modular, available in a number of cylinder configurations and of composite construction. So whereas the earlier ones were cast iron, the LW had aluminium crankcase and chain case with cast iron cylinder heads and cylinder blocks. Very interesting engine was the LK, and I'll briefly talk about that later. A very advanced engine manufactured of alloy construction, magnesium alloy. Then again the 6LX, which is the next big step in the chain in terms of the Gardner story. Available in 6 and 8 cylinder versions. It was then updated and uprated in 1966 to increase the output power. First pressure charged engine from Gardner from Barton Hall was the LXCT, and we'll talk about that in a little detail. The DT, and then the LYT. That was a brand new engine introduced by Gardner's, perhaps belatedly, but acknowledging that their traditional product line was no longer capable of meeting the power requirements that the industry was looking for. And then there was the LG 1200, an updated LXDT introduced under Perkins and manufactured in small numbers. But really, that was almost the swan song of the traditional Gardner engine family. So let's just look at these significant engines, the L2, the L3 and the L3B. As I said, available in a number of cylinder configurations. The L2 had 1.4 litres per cylinder and the L3 3 litres per cylinder. So from these engines, if you were looking at marine application, you had any capacity you might want from 1.4 litres to 24 litres. So a wide range of capacity available for different applications. As I say, the initial application was marine, but subsequently they found use in rail and industrial applications. Importantly, the L2 was small enough to be put into vehicles. So early examples went into buses and trucks. And really that demonstrated in a day when, up to that point, most of the the engines in that sort of vehicle had either been steam or petrol, that the diesel was a viable alternative. And really that was the breakthrough, I think, not just for Gardner, but the industry in general, in terms of putting diesel engines into trucks. Here's an 8L3 for rail application, 204 horsepower. If we look at it in a little detail, obviously the cast iron cylinder and crankcase construction. What you can see here is, because this was intended for marine application, there was a requirement from the Board of Trade to be able to inspect the bearings, and on some competitive engines, putting those sort of doors in place severely compromised the structure of the crankcase and made them very prone to leaks. That wasn't the case with the Gardner engine. Here you see the governor, the fuel pump and the cam box of Gardner's own design. So, and that's really indicative of the level of precision that Gardner was capable of, because as anyone who's been involved in the diesel pump business knows, that's a highly precision requirement for a very durable product. And also, in the top of the cylinders themselves, Gardner's own injectors. They call them sprayers through the life of the company. But again, so everything you saw there was Gardner. And I think that's indicative of what we probably call, vertically integrated type of company that we'd now call it. They were. So in Barton Hall Works, they had a foundry, they had a machine shop, the engine assembly, a development department, a test department, an application department. So very little of what you see there was bought in other than the raw materials. And that typified Gardner because they had this ethos of doing it all themselves. These were highly precision products. I like to think of them as like Swiss watch engineering, but on a macro scale, and a lot of hand assembly to deliver these engines. It's said that some of the drawings, while they were tolerance to normal technical standards, some of the Gardner hierarchy had written on it, make it that. So, even though they were tolerance drawings, they got specific targets within that tolerance range. So, a very successful engine for Gardner, the 8L3, and we'll come back to that in a little time later on. For the automotive applications, we're talking mainly about the LW and LX series of engines. Cast iron cylinder blocks and heads, modular design, so available in a number of cylinder configurations, 2, 3, and 4, so enabling a combination of different cylinder configurations to be assembled from those basic parts. With alloy pistons and crankcases, excluding the utility LW. That's a wartime version of the engines that were built out of cast iron to save the aluminium for aircraft, I guess, and things like that. But these were designed primarily for automotive applications. Unlike the previous ones, which were designed for marine, these were designed specifically for automotive use. Although they were used in marine, rail, and industrial applications also. Also available in vertical and horizontal versions. When we go to post-World War II, we saw the introduction in the UK of underfloor engine coaches, and so the LW engine was available in horizontal form to mount under the floor of such vehicles. Again, available in a number of different cylinder options, and the later LX just available in 6 and 8 cylinder versions. So that's a very brief overview of the approach that these engines had in terms of their design. I'd like to just take a little time to look at the 6LW. First of all, I mean, for an engine that was introduced in the 1930s, I find it a thing of beauty, particularly if you look at some of the engines that were produced, diesel engines at the time, which were perfectly functional, but grey cast iron construction, no particular sense of order about them. But here we have Gardner's 6LW, 8.4 litres, 102 bhp, and this engine was in production until well into the 1970s in various forms. Now, throughout this discussion, I'm going to concentrate on the 6-cylinder version just to allow some sort of benchmarking of the various performances. But as I've said earlier, this was available even in single-cylinder form, I believe, but certainly 2 to 8-cylinder versions. Same bore and stroke as the L2 that we talked about earlier, 1.4 litre per cylinder, but 25% lighter. I say 20% lighter there, 20% lighter. Again, with the Gardner fuel injection system, exceptionally fuel efficient, and I think you could say it's the first successful Automotive direct injection engine. So if you look at it in a little more detail, here we can see the aluminium part of it, the crankcase and the chain case. The cast iron cylinder heads, 2 3-cylinder modules here to make the 6-cylinder version. The area here, the cam box, the fuel pump, and the governor on the end here, all of Gardner's own design. Highly precision manufacture, and you can see here too some hand priming levers. So in terms of getting the engine running initially, or when you clean the fuel system out, you could hand prime each injector pump individually. And there's a very interesting characteristic. As you pumped it up, you eventually got a little squeak, and that told you that that particular pump was primed with fuel ready to go. The other thing you can just about see on here is on the end of each cylinder block is a decompression lever. So even at 8.4 litres, by operating those decompression levers and cranking this engine with a handle, you could actually manually start it relatively easily without either putting ether into it or using glow plugs or anything like that. So that was a very impressive performance from this sort of engine. Just finally, in terms of things that intrigue me, this is a generator driven by this external shaft here, but the sort of flexible couplings are like just pieces of rubber tube with Jubilee clips around them. And that design concept, again, was perpetuated in subsequent engine designs. But this LW really sets the scene for what was following. Exceptionally fuel efficient, and in fact, every generation of Gardner engine that followed this became even more fuel efficient, and that was one of the real attributes for which Gardner got its reputation. These engines were very reliable, very durable. We're talking about engines that would go 1,000,000 miles without a major overhaul, and class-leading fuel economy. And that's really what the Gardner reputation was built on. As I said, there are horizontal versions of these for going under buses in the underfloor applications, 5 and 6 cylinder versions. It wasn't just a case of turning the engine on its side, because clearly in a vertical engine you've got thermosiphoning helping with the cooling, and you've got gravity helping with the oil circulation. On the sideways view, then there's a scavenging system dealing with the oil distribution. There are drains under the cylinder heads here where otherwise oil would pool and have to be fed back into the sump, and revisions to the cooling system. But essentially these were applied widely to buses and coaches in 5 and 6 cylinder forms, and subsequently there was a horizontal version of the 6LX as well. Here's a 6LX, and contrary to what people perhaps think, this was a brand new engine. So instead of 8.4 litres, it's now 10.45. It's generally accepted to be, I think, a masterpiece is not too, putting it too extravagantly, and designed and led by Hugh Gardner. And it's probably the legacy for which he would always be remembered. Initially introduced as 150 brake horsepower, but very soon afterwards uprated to 180 brake horsepower in the B spec. Naturally aspirated, and I'll come back to that in a minute because that's very important. But now you can see, if you look at the crankcase, the aluminium still, massively reinforced, much more stiff, a lot of these external webs and internal webs, really designed to provide absolute support for the crankshaft bearings and stiffness. And significant, you can see here these cross bolts. So once the engine had been assembled, those cross bolts were put in from side to side at the base of the crankcase to reinforce the main bearings. And it was said, there was unless it had been dramatically abused, a Gardner crankshaft, crankcase, and main bearings just never failed. It was that robust. The other thing is, the early versions could be uprated to B-spec on overhaul. So again, that was a Gardner philosophy of being able to continuously improve an engine you'd already got. Interestingly now, unlike the LW, they've actually moved to CAV fuel pumps, which are capable of getting higher pressures and more accurate timing than the Gardner version. But the Gardner sprayers were retained in the cylinder heads. The other thing to say is this engine fits in exactly the same volume as the LW. So if you had a vehicle, a bus or a chassis, a commercial vehicle chassis, and you wanted more power, it was relatively easy to replace a 6LW with a 6LX. Being Gardners, you'd have to revise the cooling system and the oil cooling system because they were absolutely fastidious and quite demanding that if customers didn't meet their requirements for cooling and oil cooling requirements, they would remove the guarantee on the engine. So that was somewhat typical of a rather perhaps high-handed approach they took. I think one customer said Gardner was the only supplier they knew where the customer was always wrong. That might be apocryphal, but it sort of sets a scene that might suggest that customer relations could have been better. But I think it was actually based on the confidence that this engine was intrinsically correct. It was a good engine. And as I say, probably the engine by which Gardners will always be remembered and Hugh Gardner credited for. And this was the engine in that Daimler bus that I saw last Sunday at Rochdale. Now, the next engine I want to talk about briefly is the 6LX CT. It's the same capacity as the 6LX B to 10.45 litres, but it's now gone up from 180, 230 brake horsepower, and it's been done by fitting a turbocharger. Now, there's a story behind this because one of the aspects of the Gardner history that will come out later was, compared with some of the competition, they were always struggling for power. And that was put down in many ways to Hugh Gardner because he was always insistent that he wouldn't release anything until it was fully developed and tested and validated. And that tended to make them follow the market rather than lead the market in terms of power development. And some of the customers were so frustrated that they fitted their own turbochargers to some of these engines and 6LXBs to get greater power out of them. And of course, Gardner wouldn't support those in terms of warranty or anything like that. But after Hugh Gardner had retired, then Gardners themselves started developing a turbocharged engine, and this is it. This is the first one. So the 6LX CT, and you can see now the output's gone up from 180 to 230 brake horsepower. Massive torque. This engine was even more fuel efficient than the 6LXB, and the 6LXB, I think thermal efficiency on that actually reached 40%. It was one of the most fuel efficient engines available, certainly at that time. But the story didn't end there. The next engine was the 6LX DT, now increased in capacity to 12.7 litres, 270 brake horsepower. So a higher volume engine, higher swept capacity. It's now got a complete CAV fuel system, and it's even stronger. Increased bearing surfaces, new timing chain to support the increased loads. Again, even better fuel economy than the engines that went before. So this really was showing what levels the original 150 brake horsepower 6LXB could be developed into. However, while this engine was being developed and released, the norm in the industry was going even higher. Customers were looking for engines up to 350 brake horsepower. And a lot of that was driven by, since the 6LXB was launched originally, higher payload vehicles, higher speed requirements on motorways and so forth. And as I say, Gardner tended to be chasing companies like Cummins, who had high power engines, originally not as reliable as Gardner and not as fuel efficient. But over this period, the competition caught up. And for people looking for even more power than this, clearly there was the 8LX, the 8-cylinder version. The problem with that was, in terms of its cost and complexity, it was an expensive engine. It was once described as the smoothest automotive diesel engine ever built. So in terms of refinement, it was an excellent engine. But packaging an 8-cylinder engine in a rigid chassis fixed cab truck of the 60s and 70s was quite difficult. Later on, as articulated vehicles came into play, then the length could be accommodated at the back of the cab. But nonetheless, this was almost the ultimate development of the 6LX family of engines. Now, chasing the increased power, in Hawker Siddeley days, the 6LYT was launched. 15.5 litres, turbocharged from the outset, described as new from the sump plug up. It was a metric specified engine in terms of dimensions, developed under Hawker Siddeley, and with automotive and marine versions available, and future-proofed. So even though it was launched at this sort of power, it was envisaged it could be, by continuous development, increase significantly more to keep in line with the competition. Now, I was speaking to someone who helped me prepare this presentation about what happened, because when it was launched, it had some reliability problems. And it appears that some components, which by this time were being bought in on the Hawker Siddeley, had some minor defects, which caused almost a chain of failure events in the engine that effectively caused engines to fail in the market quite drastically. And things that might have been caused by saving a penny here caused engines to fail in service. And it really damaged Gardner's reputation for reliability. Now, because they were trivial things which should have been developed out at source, it was very easy to fix those problems. And this engine became a very successful and reliable unit. And many are still in service today, particularly in marine applications. But that damage that was done to Gardner for that unburstable reliability really probably hastened the change of customers away from Gardner engines, when this engine should have been potentially something to help them going forward into the future. Finally, the LG 1200. This is an updated 6LX DT, developed under the Perkins regime. Turbocharged again and possibly intercooled. Significant change to this was, on the previous engines at the front end, we had a chain cover and a chain-driven camshaft. On this engine, they were gear-driven. And the consequence of that was the engine could be made shorter and lighter, so easier to package. But this probably came too late to really have any significant impact in the final days of Gardner. I think it was offered by Dennis in some of their buses, but never really taken up in any volume. I'll just go and talk about the 4LK. I'll come back to it later in a bit more detail, but a compact, very beautiful engine again in terms of its appearance. Similar sort of construction to the LW engines, but at a detail level significantly different. Fitted into a number of cars on an individual basis, but also small trucks supplied by Foden's, small buses supplied by Dennis, and so forth. And after the war in the early 50s, one was fitted with XK150 Jaguar. Not quite sure what it did for the performance, but it achieved 90.85 miles per gallon in the mobile economy run. But these engines also found themselves into quite a number of prestigious vehicles. If we look at this Rolls-Royce, it looks exactly what you might expect from a Rolls-Royce. But when you look at what's under the bonnet, we've got a 4LK Gardner, and it looks as though it's absolutely made for the job. So that's just an aside in terms of the 4LK engine. So, what were these engines used for? As I said in the early part of the presentation, the L2 and L3 engines were designed initially for marine applications. So I just want to talk a little about some of those applications. It was said at one time that 30% of the British fishing fleet had Gardner engines, and it wasn't just those working boats they went into. They went into ferries, freighters, lifeboats, luxury yachts, and so forth. And so widely specified. The larger engines for propulsion, the smaller engines for auxiliary power supply, power units to drive generators and so forth. And it's not uncommon to find a larger ship with two, maybe 8L3s for propulsion and maybe a 4LW driving generators and what have you. Again, longevity, reliability were the key factors that sold the concept of Gardner engines to working boat owners. And here's an example of the 8L3B for marine application. I think this engine's so beautiful. I'd have it in my lounge if it would fit, and my wife would let me. Also, just to point out that we've seen a version of this previously when we looked at the engine specifically. But on the rear here, we've got a reversing gearbox. Gardner also supplied their own gearbox for marine applications on twofold, really. One, they wanted to ensure that the quality of the gearbox matched the engine. And I think there was more subtle concern that if they allowed a third-party gearbox to be fitted to their engine and there was a problem, who would take responsibility for it? But that, I think, is an engine that has found major applications, and lots of these are still in use today. A lot of them ended up in places like China and things like that, and are still working on in day-to-day applications. But not only the 8L3, the 6LXB also found marine use. You can see here again 2 engines ready for shipping, again with marine gearboxes attached to them. And here's a picture of the Gardner marine transmission. 2 versions, one for the LW and LX engine and one for the larger engines, offering direct drive or 2-to-1 or 3-to-1 reduction. So again, part of the plan to offer a complete system to their customers. I've taken this out of I think it was off eBay actually this year. It's an advert for a boat in Australia, Sabatine. But when you look at the spec of it, yeah, this is all. But it's a 1998 built ship, so it's relatively modern. But one of the attributes that they're advertising is a six-cylinder 6LX engine. So even today, after the demise of the Gardner company, it's still seen as a benefit in terms of offering a reliable and attractive feature in terms of propulsion on a luxury yacht. Gardner also featured in the war in a number of ways, and one was in the X-class submarine. This submarine had quite a devastating effect on some of the German warships, particularly the Tirpitz. And while it was on the surface, it was powered by a Gardner 4LK engine. It must have been a bit cosy in there, but you can see because of the compact size of the engine, it was packageable and really a very important element of that, designing those X-class submarines. Another area where Gardner engines were well used and applied were in lightships, where you wanted an engine that, other than occasionally providing it with fuel and oil, it would just run day in, day out, week in, week out, keeping the batteries charged, ultimate reliability, and you'd get the sort of gensets like this. This is I think an L2 two-cylinder driving a small generator, perfectly capable of charging the batteries and keeping an unmanned, in some cases, lightship fully operational. Gardner engines also found themselves into RNL line lifeboats. This is a Solent class lifeboat, and you can see here two 6LX engines mounted deep in the hold to try to contribute to the stability of the boat, tend to prevent it from capsizing. This class was launched in 1973 and continued in service in the UK till 1993, when they were retired for more modern boats, but the fleet was then sold on to Uruguay, and they've been in service in Uruguay till this year. And again, if you look on eBay or some other sites, these boats are now up for sale, but not as scrap or anything, as working lifeboats. Apparently, Uruguay have changed the spec to require things that are faster than this Solent class boat is capable of doing. But again, just showing the arduous applications and the long life that the Gardner engines offered for this sort of application. Where else do you want reliability? Well, how about lighthouses? This is the Lizard lighthouse, and what you can see here is a 4LW engine driving a generator and a compressor, the generator for the light and the compressor for the foghorn. So again, something where if you're looking for a safe, reliable application, here was a Gardner product capable of providing it. During the war, a number of forts were built in the Thames to try and protect the shipping lanes, and I think this is the Navy version, I think. But inside they had Gardner 6LW powered gensets. They were presumably the utility version. And in the late 40s, these forts were abandoned and really just left as they were until the 1960s, when a number were occupied for pirate radio stations. And if you read the autobiography of Prince Michael Bates of Sealand, when they occupied their fort, the first action they took was getting, as he put in his book, the Gardner 6LX gensets working to enable the rest of the operation to take place. So again, a bit of an off-the-beam application of Gardner engines in marine applications, but nonetheless significant again in terms of their reliability and durability. Now, towards the end of Gardner's life, when the automotive business was declining quite dramatically, they introduced, I think this was late in the 1980s, a 2LW engine for narrowboats. In fact, I think the LW range had been discontinued years previously, but almost to try and recreate a marine market. A 2LW version was introduced fairly late on, and it found and is still used quite significantly in narrowboat applications. So, overview of the marine side, wide, varied applications, again, emphasising the benefit of Gardner, reliability, durability, and fuel economy. But it wasn't just boats. As I said, applications moved into rail. And there was a sort of niche area where gardeners worked with Walker Brothers of Wigan. Walker Brothers were the proprietors of the Pagefield Ironworks, and they made both diesel-powered lorries and diesel-powered locomotives and rail cars. And this is one of theirs for the West Clare Railway in Ireland. Again, as we found in the British side of things, in the 50s, narrow gauge and small branch lines were struggling to be profitable or viable. Steam locomotives were replaced, and Gardner and Walker found a niche providing this sort of locomotive to replace steam and improve the economy in that sort of application. Walker and Gardner also were very successful abroad. So this on the left is a rail car provided by Walker for, I think it's the Emu Bay Railway in Tasmania, and again another application on Ireland on the right. I'm not sure which railway that is, but it's quite similar to ones they supplied to the County Donegal Railway, of which a pair are still extant in the Isle of Man. So if anyone wants to see one, I don't know whether they're running now, but the last time I went there, they were. And what Walkers and Gardner really did was make this power bogie end. The coachwork could be provided by someone else, as can be seen by this next slide, where Walkers provided for Australia quite a wide variety, built over quite a significant period of time. Walker did the power bogie end, and the car bodies were built locally by Martin and King in Melbourne. 79 in total were provided and lasted significantly up to 1988, and several are preserved. So again, an important market for Gardner through Walker Brothers and the Pagefield Ironworks. They actually had an application in the UK in the 1950s when the British Railways were trying to economise on the costs of running small branch lines. A number of rail cars, four-wheel rail cars, were bought from manufacturers who weren't necessarily traditional railway manufacturers. So AC Cars built some, AEC, the bus builders, built some, and this was supplied by Bristol and ECW. Now, Bristol and ECW are well-known bus manufacturers, and we'll talk about them earlier. And they built two of these with a Gardner 6HLW engine incorporated in them for propulsion. And these operated relatively successfully for about 10 years in the Scottish branch line application. But by the time they had come to the end of their life, the modernisation plan, the beaching plan had been announced, and none of these four-wheel cars was perpetuated because the lines for which they were built probably closed. So it was a bit of an aside, but nonetheless, I think probably the only main line as opposed to shunting application I know of a Gardner engine on British Railways. But this was much more familiar to most people, particularly rivet counters like me. The Drury 03 shunting locomotive with a Gardner 8L3 engine, 204 brake horsepower. 625 of these were built by Drury, but also Gardner engines, either 8L3 or 6L3, found their way into locomotives from Vulcan Foundry, Robert Stephen Hawthorne, Barclays, Hudswell Clark and Hunslet. So in total, over 1,000 of these shunting locomotives were supplied to British Railways in the 1950s and 60s. The locomotives, certainly the Drury versions, were highly successful. There aren't many of them around now, in contrast, say, to the English Electric 350 horsepower shunting locomotive, which is still widely used. The reason being that these were really targeted at small marshalling yards dealing with wagon load traffic, which has now largely disappeared as containers and bulk transportation of commodities replaced wagon load freight. But nonetheless, a number of these locomotives were sold either to private industry or preserved railways, and there are still quite a number of them operating today with their 8L3 prime mover. So that's a quick look at railway applications. I'll have a probably even quicker look at some industrial applications. Now, I'm going out of time here because this is a HF engine for a Ceylon tea plantation. It actually predates the period I'm going to talk about, but I've brought this in just because of some lovely photographs I'd like to include in this presentation, just to show the lengths people would go to have a Gardner engine in any corner of the world. So the first part of the journey in Ceylon was actually the engine in that crate being transported by elephants. And when it eventually got to its final destination, it was being pulled by oxen. I just think that's really a nice tribute to the way the Gardner engines were appreciated and the trouble people would go to get one. But anyway, coming back a little more up to date, Gardner engines were supplied to a lot of independent manufacturers of industrial equipment. I think this Priestman, I think this excavator. Anyone remember these? Growing up in Merseyside after the war, there's a lot of bomb damage being replaced and pneumatic drills everywhere. And I always remember, when the drills stopped, you heard the compressor revving up a bit, and they were always Broomwade, British made, and they tended to have either a 5LW or a 6LW engine in those. So just another typical application where Gardner's durability in particular was very appropriate to the use. Now, buses are probably the area where Gardner engines are most recognised and famous. And just a quick summary of how things were, certainly after the Second World War. There were municipalities who bought buses. So if I talk about Manchester Corporation, as one I know, they had large fleets of Crossley, Daimler and Leyland initially after the war. So they could buy more or less what they wanted. You then had the Tilling Group. The Tilling Group was nationalised after the war and contained a number of companies like Crosville, for example, one we knew locally, and they had their own bus supplier, which was Bristol, and their own coach supplier, Eastern Coach Works. So not absolutely were they forced to buy buses from that group, but if buses were available from Bristol and Eastern Coach Works, Tilling got them, and equally they weren't available generally to non-Tilling Group people. BET, derived originally from British Electric Traction, was a group of independent bus operators. I think names like Lancashire United and North Western Road Car Company, I think, for example. So these were areas where potentially Gardner engines could be applied. There were also private coach operators. In Rochdale there was Yellowway and there was Allen Smith, and they tended to buy standard AEC or Leyland chassis and tended to have, therefore, that supplier's own engine. And then there were what we call light coaches. These were sort of secondary designs. It's provided by, say, Ford or Bedford or Commer. They had their own chassis, they had their own engine, normally front mounted. So again, although there were, I believe, some Bedford coaches with Gardner engines, there were very few and far between. So in buses, we're talking about this group as potential Gardner customers. And these are the suppliers that were very prominent in those days. So I'm going to talk a little bit about most of these. I'm going to use Rochdale as an example because that's where I grew up. And here's a Rochdale CVG6. A large fleet of these was bought just after the war. The first modern buses bought by Rochdale. In general, the majority had 5LW or 6LW. The G6 here means it's a 6-cylinder Gardner engine. I've travelled on this bus, so it's quite familiar to me. They were normally fitted with Wilson pre-selector gearboxes as well, and that was a sort of standard offering from Daimler in those days. Daimler did actually have their own engine for a while, but most customers chose the Gardner option, and after a while the Daimler engine was discontinued. The next batch of buses Rochdale bought were these, AEC Regent 5s, but a unique spec. So whereas the standard AEC had its own engine, they specified the Gardner 6LW, and initially with the Wilson pre-selector gearbox. And the bodywork's actually identical to those Daimler CVG6s. So I've always been a little curious why they didn't just buy more Daimlers. There must have been a reason at the time. Because other than the chassis and the back axle, mechanically and in terms of bodywork, these were the same as the Daimlers. And if you rode on one of these buses and kept your eyes closed, you would think you were on a Daimler CVG6. Later ones had AEC's own engines and what have you. And then this is Daimler Fleet Line. Again, I used to live on the 19 bus route, so I'm familiar with this bus quite quite extensively. A highly successful competitor to the Leyland Atlantean. The Atlantean was launched in 1958. This was introduced in 1960. Over 7,000 were built, and the Gardner 6LX engine was standard. And again, very successful, exported in a number of overseas territories. Latterly, when Leyland had bought the Daimler company, it offered its own 0680 engine as an alternative to the Gardner, but there wasn't much take-up of that because people using the Leyland engine probably would buy it in the Atlantean anyway. And this was discontinued in 1980. But the Gardner engine was really a benchmark in terms of the success of this vehicle. It was just known for its reliability, its ability to withstand the sort of cyclic operation of buses with extensive periods of idling, then lots of stop-start type of operation that provided levels of fatigue that caused unreliability problems on some of the alternative engines. In terms of Bristol and the Tilling Group, then the standard bus sort of post-war, this is a K5G. The 5G means it's got a 5-cylinder Gardner engine. Bristol were very innovative. Soon after the war, they introduced the low decker. The interesting aspect of this was that unlike most buses where you got onto the platform and then had to stand up about a foot to walk down the lower saloon, Bristol introduced a split drop centre rear axle, which meant the bottom floor of the bus could be the same as the platform. So enabling it to be step free, and also reducing the height. So this could be a lower, what we used to call a low bridge version, a bus that was capable of going under lower bridges. So a standard bus was about 14 feet high. This was probably about a foot lower than that. The Bristol RE, a big user of the 5HLW and 6HLW, the horizontal version of the LW engines. And latterly, the VR. This was Bristol's version of the rear-engined buses like the Atlantean and the Fleet Line. And because it was the last on the scene at the time, it was probably the most successful in terms of technical performance. And again, the 6LX was the standard engine for the VR. Guy was a much more conventional sort of bus supplier, based in Wolverhampton. The Guy Arab on the left was a design that went back to before the war. It was one of the few buses that was built during the war as a utility model. During the war, it was offered with a range of engines, including the utility Gardner engines. But afterwards, Gardner became the standard engine for the Guy Arab, and it was widely used by some of the BET and municipalities. On the right, we have the Wulfrunian, interesting bus. This was Guy's answer to the Atlantean and the Fleet Line. Looks very similar at first glance, but this is actually a front-engine bus. It had a Gardner 6LX at the front, and this bus had a lot of really innovative design features in terms of the suspension and the brakes and what have you. That's now commonplace on modern buses. But by putting it on this Wulfrunian with this huge forward weight bias of the Gardner 6LX engine in front of the front axle, some of the benefits that the new suspension and brakes were designed to overcome were actually exacerbated on this bus. And they actually had to take seats out of the front of the top deck to reduce the weight. So a bit of an own goal, and only about 137 of these were actually built. It said they were the cause of Guy going into administration. That's not really the case, I think. It was part of a bigger scene. Dennis, another well-known make now. Up until the 60s, Dennis had been a bit of a bit player in buses, with buses like the Lance and the Lancet, small buses that preceded it. But they then introduced the low line. If you remember the Bristol low decker that was available for the Tilling companies, well, for non-Tilling companies, Dennis manufactured a version of the low decker. It was called the low line. It actually had some more advanced features than the low decker, but again brought Dennis back into the mainstream bus business, although subsequently they faded out again. But towards the end of the life of the Gardner story, there was a lot of, as we'll see later, Leyland really dominated the bus industry, but And so a number of new buses were introduced as alternatives to the Leyland offerings. And this was the Dennis Dominator. Very successful, over 1,000 built, and a number of different Gardner engines offered over the life of the vehicle. Towards the end of its life, alternative power units became available, including Cummins, and ultimately Cummins became the major power plant provider for subsequent models. But Dennis came back into the mainstream with this bus, and now, in conjunction with Alexander the Bodywork, Alexander Dennis is the largest global manufacturer of double-decker buses, mainly with Cummins engines, I have to say. Another alternative to the Leyland offerings was Metro Camel Wayman, known as body manufacturers and rail vehicle manufacturers. They introduced the Metro bus. Over 4,000 were built, including 1,400 for London Transport, again with a 6-cylinder XP as a standard power plant. So again, these were offerings for bus operators who were being concerned about the domination of Leyland and their control of what was being made available to them. A very successful bus, this one. Another one not so successful was the Foden NC. Foden and Northern Counties put together this bus. Foden, again, had been a small player in the bus industry and decided to develop something as an alternative to Leyland's offerings. And this is a Foden chassis with Northern Counties body. What engine would you offer if you were going to give something that was acceptable to the customer? You'd go for the 6LXB engine. It had a Frodo retarder, which was quite advanced in its days, and an Allison torque converter transmission. The problem was the transmission characteristics and the engine weren't matched, so there was actually a step-up gearbox between the engine and the transmission to make the thing work. But as we know, generally with torque converter-only type transmissions, they're not particularly fuel efficient. And in this application, it was unreliable. So the benefits you might have from a Gardner engine were negated by the unreliability of the transmission. And apart from a development vehicle, only 7 were sold. But I think actually 2 are still extant in preservation. Now, this is an interesting one. For obvious reasons, Leyland normally never offered Gardner engines in Leyland buses because they had 2 very successful engines of their own, the 0600 and the 0680. Perhaps not in the Gardner class, but very worthwhile engines, widely used worldwide, reliable, reasonably fuel efficient. But Leyland, we're probably all familiar with the decline of Leyland as a car manufacturer. Essentially, something very similar happened on the commercial vehicle side. So from going in the 1950s to a world-leading, highly respected supplier of commercial vehicles, by the 1980s, they'd gone the same way as the car side. But to support the development of 2 new integral construction buses, which Leyland had tried a number of occasions to introduce previously. For example, the Atlantean was originally integral construction in terms of the prototypes, but were rejected by potential customers. But they tried again with the rear engine Titan and the National bus, and we probably all remember the National bus. And for that application, for those applications, they developed this new engine, the 0500. One of the perceived problems of the 0600 and 0680 was cylinder head gasket failing. So in this quite radical design, they decided to avoid that by having a monoblock construction. There was no detachable cylinder heads. And this really could have been a highly successful and really advanced engine design. But what happened was halfway through the development of the engine, Leyland management decided what had been developed was too big physically and too big from a swept capacity point of view, and they ordered a redesign, and that was the outcome, the 0500 engine. As a consequence, development was rushed, it wasn't well proven. When it was put into manufacture, I think it was made at the former Spurrier Works in Leyland, quality control was bad, tolerances weren't met, castings were porous. It was highly unreliable, complex and costly to repair. And it got to the point where people were reluctant to buy the National bus because of this engine. And in fact, a number of national bus operators took it on their own bat to retrofit Gardner engines to these vehicles. And that was quite difficult because this engine was significantly smaller. So to fit the Gardner, they had to cut away the bodywork, cut away the floor, put a new cooling system in place. But the business model said if you could get 5 more years out of the bus with a second-hand Gardner engine, that was a good deal. So this engine, originally rated as about 230 horsepower or more, was gradually derated to, I think, what they call the long life version, which is derated to 170 brake horsepower, actually less than the 6HLX-B, and was just quietly discontinued. So when the National 2 bus was launched, it was offered with the Gardner 6HLX-B engine. So quite an indictment of what happened to Leyland, probably not as well communicated as what happened on the car side, but a similar approach, ruining a reputation built up over years to a really high standard with a few very poorly made management and engineering choices. So an opportunity, it was the first non-Leyland engine offered in a Leyland bus. So that's quite an interesting outcome. But what happened at the end of this? Well, as inferred or as implied by these competitors coming in from Metro Campbell and Dennis, Leyland gradually absorbed all the traditional bus builders in the UK. So they bought Guy in the aftermath of the Wolfronian and a failed export contract business, closed it in 72. They took over Bristol and closed it in 83. Daimler was assimilated into Leyland and discontinued in 83, and AEC ceased production in 77. So all those major customers for Gardner really disappeared in the wake of the Leyland taking over this business. As I say, the Leyland National briefly offered the 6HLX engine in the National 2, but that was discontinued after only 3 years. And then in 88, Leyland was purchased by Volvo, who of course had both their own buses and their own engines. And the brand was eliminated in 1993, by which time Gardner had ceased making engines. We've mentioned the failure of the Foden NC bus, and Metro Campbell, who had been very successful, went bankrupt in 1989. It was a group, quite of an extensive engineering group, and the group failed. Dennis continued. As I say, they're still now a significant builder, the biggest builder of double-decker buses, but used mainly Cummins engines. And while all that was going on, in 1986 we had bus deregulation. So the big fleets of municipal buses, where a number were replaced every year on a rolling basis, all that suddenly stopped. Those municipalities were broken up. A lot of the business was split between new bus companies, many of whom had second-hand buses. They'd got no capital to buy new buses. So there was a lull in the purchase of new buses, and a lot of the buses run by the deregulated companies were more minibuses, some of them on truck chassis and things like that. So with the core of the Gardner business disappearing and bus deregulation putting additional noise into it, the outcome of that was pretty serious for Gardner, because the bus industry was seen as their major customer and application. Just briefly, commercial vehicles. I talked about the badge on the front of the bus the other day. Well, this is the sort of badge. Gardner 180, that means it's a 6LXB. And as I said, very early on, Gardner engines were introduced by Pagefield, who were the Wigan, Pagefield Ironworks, Walker Brothers at Wigan. But these were the major customers with which Gardner engines are normally associated. A couple of pictures of early Pagefield lorries fitted with Gardner engines, just out of interest. But if we look at the volume commercial vehicle manufacturers, Foden, ERF, Scammell, Atkinson and Seddon, they were ones that were usually very clearly associated with Gardners. Foden, originally a steam wagon manufacturer, introduced diesel vehicles. I think this was 1933-ish, something like that, maybe a bit earlier. This is the first one, fitted with the Gardner engine. And Gardner was offered throughout the life of their availability and the life of Foden. Foden, of course, developed their own engine as well, a two-stroke engine, which was fitted in some significant volumes, but the Gardner engine was always the preferred one. And you can see here the little badge on here that said this was fitted with a Gardner engine. Similar situation with ERF, some of the earliest ones here on the left, but again, says it's got a Gardner engine on here, and the one on the right. So, and I think it's true that at some stage in their life, Gardner actually purchased a shareholding in ERF, as it was seen as a route to market for their particular products. Atkinson and Seddon Atkinson, again, Gardner, I think it's a 240, so that's probably 8LX, and again a 240 on here, an 8LX engine. So again, the sort of customers that featured Gardner engines very significantly. Now this is interesting. In 1983, a vehicle from Seddon Atkinson fitted with a Gardner 8LX CT engine won the Round Britain economy run, and this is one of the adverts that Seddon Atkinson put out to celebrate, and you can see the badge has been updated a bit, but Gardner engine. I asked one of the chaps who worked at Gardner at the time how this was exploited, and he said, well, actually, Gardner really didn't take much of an opportunity here, because it was just before they were launching the 8LX DT and the 6LY engine at the next year's motor show, and they didn't want to detract from those new engines by over-publicising this. It just seems remarkable, an opportunity lost, but a very significant outcome for Gardner, fairly late in the life of the company, as will be seen. Now, when you look at probably can't read them from here, but why the Gardner engine was so efficient in these sort of applications, what we see here is the characteristics of the Gardner engine. What you can see is, as the BHP goes up with speed, the torque curve and the fuel consumption curves are actually flat. So all that contributed to the fact that whatever the usage cycle of the engine was, you got a consistently high torque output and efficient fuel use. This on the side, again, you probably can't see, but this is SFC of a number of competing engines. So this is the Gardner at the bottom here, Leyland, I think 0680, 0600, and the Rolls-Royce Eagle. And you can see that the Eagle, for example, is 17% increase in terms of fuel consumption of the Gardner, which, if you're doing hundreds of thousands of miles a year, is a very significant cost. And those two graphs really sort of crystallise, in my view, what it was that made the Gardner engine special in terms of their overall fuel economy in their applications. And then there was Scammell. We probably all remember getting stuck behind these at probably 5 miles an hour, taking a transformer from Stafford English Electric to Liverpool docks. Normally one at the front and one at the back. Probably got a 6LW engine in them, certainly a Gardner badge on the front. If you're only doing 5 miles an hour, you don't need a lot of power, you just need low gearing. And so Scammell was a very considerable user of Gardner. But again, as applications for faster transport, more power came out, Gardner found itself marginalised, and other power plants were put into the Scammell vehicles. So if you look at the British truck industry, you see a similar situation to what happened with the buses. In 1970, Atkinson amalgamated with Seddon, and in 1974, International Harvester took over Seddon Atkinson, then in Iveco, and in 2004 closed. Similar with Foden, the first diesel in 31. In 1980, was taken over by Packard, who were very close to Cummins in terms of engine suppliers, closed in 2006. ERF, again, taken over by Western Star in 1999, and then MAN in 2000. Anyone who was involved in that will remember there was a huge financial scandal, and in 2002, the manufacturing in Sandbach was closed. The brand continued as a badge engineering application for the UK for a while after that. And then similarly, Scammell in 55 became part of Leyland, then DAF, and was closed in 88. So you can see again that even though the use declined, all these customers that had been the staple users of Gardners over the years, along with the buses, by the end of the 80s, were disappearing or had gone. So, why did Gardner ultimately fail? Well, usually these are the quoted reasons. Shortage of power compared with competitors, reluctant to adopt pressure charging to increase the output, the 6LY unreliability issue we talked about earlier. The other thing was, although these were precision manufactured engines, hand assembled, in the heady days of Gardner's operation, demand always exceeded supply. And the output from Barton Hall probably never exceeded about 4,000 engines a year. And rather than try and address that and satisfy the customers, Gardner sort of rationed the engines or even charged customers a premium to get their engine in the front of the queue, which might have been a short-term perceived good business, but longer term meant it was opening opportunities for the competitors to move in. So delays in filling orders. There were two significant strikes in Gardners in the 1970s. They were quoted as being contributors to the demise of the company, but actually in the context of the times, the British Leyland and the Red Robos probably not that significant or in the overall scheme of things. Cost compared with the competitors, well, certainly they were more expensive. They were hand assembled. When they were doing 3,000 a year, Cummins were doing 30,000 a year. So they never really were competitive in terms of cost. And they were certainly slow to react to competitor threat. As I said earlier, they were always short on power compared to what the competition had to offer. And some inept management decisions by owning companies. For example, under Hawker Siddeley, they introduced a large automated machining centre for crankcases. But because the rest of the engine was handmade, they never really managed to get the benefits from that otherwise you might have anticipated. So actually, and this is my view, this is just the Evans view of life, the real reason was its customer base disappeared. And it continued to have a niche business in marine applications, but compared with the volume of commercial vehicles and buses, not enough. The other thing is the market changed anyway. The days when a truck operator might buy one, keep it 10 years, run it for 1 million miles, they'd gone. Now vehicles are coming in from abroad. They got luxury features, sleeper cabs, air conditioning, and British truck manufacturers were really slow to catch on to that sort of thing. And they became commodities. I remember talking to someone at Ford who introduced a truck in that sort of era. And this truck was designed for a life of 250,000 kilometres. After that, it was done. You bought a new one. So the business model changed as well. Also, and this is from a colleague I've been speaking to who worked at Gardner at the time, Hawker Siddeley didn't really appreciate the cyclic nature of the commercial vehicle business. So as the volumes dipped following the bus deregulation and so forth, that was seen as something that they really couldn't conceive and accept from a management point of view. And then finally, when Perkins bought the company, they actually owned Rolls-Royce at the same time. And it turns out that they went around trying to promote Gardner customers to use Rolls-Royce engines, which clearly had an impact. So they're my views really on what brought an otherwise successful company to a probably an inevitable end, as it turned out. So what remains today? Well, there are many Gardner engines still in daily use worldwide. There are several specialist companies supporting them with spares and overhauls. And for grandfather rights on emissions and things like that, these engines have to be sold as reconditioned. You can effectively buy a new Gardner engine today if you want one from a number of these specialist companies. An aerospace company with links back to Gardner and Sons is active and successful. Gardner Aerospace. When Gardner went bankrupt, a group called Gardner Group was formed, and out of that, one of the outcomes was the formation of Gardner Aerospace. Now, other than there's precision engineering involved in it, there's no real links other than the name, but it is a harking back to the original Gardner company in some way. I think it's now owned by the Chinese, but there you go. There's also a thriving interest group, the Gardner Forum, of which I'm a member, trying to communicate the story and the legacy of this British company. And interestingly, the original company, Gardner and Sons, although dormant, is registered by JCB. So what their intentions might be on that score, I'm not too sure. So here's Gardner Aerospace, which I talked about. Paul Gardner Engineering, that was the last Gardner family member who, when the company was reaching its conclusion, set up his own remanufacturing business for many years, until the point where people were no longer prepared to pay the full price, if you like, to keep the engine to the Gardner prescribed standards. But Walsh Engineering, again, still producing Gardner engines. Gardner Marine Diesel, specialising in marine applications, of course, and Tangent Engineering. All of these are customers that focus either exclusively or predominantly on Gardner, supporting the engines that are still out there in business. So that's the end of my presentation. I'd like, first of all, to thank two people, Eddie Rayner and John Naylor, both of the Gardner Engine Forum, who've helped me significantly in putting this presentation together. I couldn't have done it without them, so thank you to them. And thank you to all for coming along and hearing my story on Gardner diesels of distinction. Thank you very much. Yes, of course. Right, okay.
So if you're in a museum, how can you spot a Gardner engine? Is it symbol?
Well, there's the logo, so that's well recognised. If you go, for example, to the Anson Engine Museum, they've got a wide range of Gardner engines there. I think you can see them straight away just by the appearance. They look refined, they look sophisticated. If they're in good condition, they've got a lot of bright work, polished alloy, and what have you. And there's a Gardner logo on the fuel pump, on the it's that. Yes. They are. There are several, so they're not unique, but the styling is very evocative of Gardner, shall we say? So when you see one, you will recognise it. Yes. Yes, they exported to the Empire, as it was, and then the Commonwealth. Engines were sent in large volume to South Africa, Southern Africa, some went to North America. I mean, in the 50s, most of the big trucks in America were still petrol powered. Diesels were quite a novelty in there, and a number of Gardner diesels went to North America and really spearheaded the launch of diesels into the truck market there. They went to Australia in the rail applications, places like Tasmania. So I think a lot of places with British connections use Gardner engines, either buying them as prime movers or in the products. For example, a number of the South African trucks were supplied as fully knocked down kits from the British manufacturers, including the Gardner engine, and they were assembled there. Also, Gardner licensed their designs to a company called Cromhoe in Holland, who initially made Gardner engines to the Gardner design, and latterly, whether officially or unofficially, used some of the Gardner concepts in engines of their own design. So, but I think the story I hear is that Gardner were very conservative in terms of holding on to their what we call IPR, I suppose, these days. And again, I don't know whether it's true, but there's a book called a book on Gardner engineering, engineering excellence, and in there it's claimed that Gardner didn't do any competitor teardown. You know, they just focused on developing what it seems incredible these days, because we have whole departments now in businesses doing nothing but that. So whether it's true or not, I don't know. Celebrated Engineering Excellence is a book called by Graham Edge. It's a really good read if anyone's interested in the Gardner story, and much more detail than I can tell you in an hour. But yes, they did find themselves, well, a lot of the Gardner engines that came out of buses and trucks that reached the end of their lives were reconditioned by some of the people that we talked about now. And in places like Hong Kong and China, they find wide application in junks and fishing boats and things like that, again for their reliability and things that go with that. So the story is not over, I'm pleased to say, and I think it's important that even though people of a certain age remember gardeners, I think now, as time goes on, people just need to be reminded of it, how important they were to British industry and the British reputation for engineering excellence. Thank you.
What I'm going to do is, before we do anything, stop the recording.
Thank you.